Hello, students. In this lesson, we will learn how to define methods inside a class. In the previous lesson, we discussed how to define member variables in a public class. Now, we will focus on how to define methods that represent the behaviors or actions of the class. Before we define methods, let's take a look at this class. In the previous lesson, we discussed the person class, which we declare as a public class using the public keyword, indicating that it is accessible from outside the class. Inside this public class, we defined three member variables: name, age, and height. These member variables represent the attributes and characteristics of the class. Now, let's explore how we can describe the behaviors or actions of the class. This introduces the concept of member methods. Member methods are used to define the actions or behaviors of the class. For example, in the person class, as people, they have various actions they can perform. One such action is working. So we can define a method to display a message like someone is working. Similarly, people can sleep. So we can define a method to display a message like someone is sleeping. In summary, member methods, along with member variables, are used to represent both the attributes and behaviors of the class. In this lesson, the focus is on how to define member methods. Let's take a look at how we define member methods inside a class. The code provided by me is an example of a member method. A member method consists of two parts: the method header and the method body. The method header provides constraints for the method, such as modifiers, whether it has a return value, and whether it requires parameters. On the other hand, the method body contains the actual implementation of the method's functionality. Now, let's break down the method and gain a good understanding of its components. In the method header, the first element we need to discuss is the public modifier. Modifiers are used to control the access permissions of the method. Apart from public, there are several other modifiers, such as private, default, and protected. It is essential to note that if we want to define a method with default access, i.e., package private, we should leave it empty. Default, we should not use the keyword default itself. The default keyword only represents the default access level, but we should not include it in the code when defining a method. The second element we want to talk about is the return type. Int in this example, the return type defined by me is int, which stands for integer. It means that after this method is executed, it should return an integer value. When we define a method and it needs to return a value, we must specify the exact return type. For example, if we want to return a single precision floating point number, we need to define float as the return type. If we want to return a double data type, we use double. Similarly, if we want to return a string, we use string. For a Boolean return type, we define it as Boolean. We can also define methods that return arrays, such as an integer array or a string array. So, can I choose not to return anything with this method? Certainly, you can. The methods support not needing to return any data. When I don't want this method to return anything, we use the keyword void to modify it. Therefore, when we define methods, if we don't want to have a return value, we replace int with void in this position. This is the second key element, the return type. Additionally, in the method definition, the third element is the method name. As the name suggests, it should provide a brief description of the method's functionality. For example, if we want to define a method to add age, we should write @age. If the method is intended to retrieve a date, we can name it getDate. When defining method names, it is essential not to use confusing names like A, B, C, or D. Instead, we should choose names that allow others to understand the intended functionality easily. For instance, max typically returns the maximum value, while min returns the minimum value. Therefore, although method names can be freely chosen, it is recommended to make them self-descriptive. This is the third element, which is the method name. Moreover, if a method name consists of multiple words, we suggest using lowercase for the first word and capitalizing the first letter of subsequent words. Next, let's talk about the fourth crucial element in the method, header, which is the method's parameters. After the method name, you will find a set of parentheses, and inside these parentheses is where we define the method's parameters. The parameter list is written in this location. In principle, a method can have any number of parameters, but I recommend not defining too many. Generally, it is best to have around 5 to 6 parameters at most. When you define too many parameters, it becomes harder to remember them all. So, we generally recommend defining a maximum of 5 to 6 parameters. These parameters are also known as formal parameters. But what are formal parameters? Formal parameters are only valid within the method. They are not actual values. For example, suppose I define two formal parameters, number 1 and number 2, inside a method, and then compare them to output the maximum value, or number 1 and number 2 concrete values. We know that number 1 and number 2 can be compared, and we output number 2 as the maximum value. However, the formal parameters here are not concrete values. They are just representations. Just shows. Number 1 second and number 2 seconds are placeholders. When we make specific method calls, we actually pass values to them. For example, number 1 and number 2 could be assigned a specific value respectively. Only then will the comparison take place. When defining parameters, we need to specify two things: the parameter type and the parameter name. When defining multiple parameters, we separate them with a comma, which should be a lowercase English comma. It's essential not to make mistakes. The parameter type can be freely defined, such as int, string, double, or boolean. There are no strict restrictions on the parameter type. However, it's not mandatory to define parameters for every method. When creating simple methods that don't require specific inputs, we can choose not to define any parameters. Therefore, whether to define parameters or not depends on the functionality and requirements of the method. This concludes our explanation of method definitions. Next, after defining a method, we certainly need to use it. Let's take a look at the person class that I have written. Inside the person class, there is a method called eatFood that prints, I love eating what food. To call this method and let the system know what food I love to eat, we follow the same process as calling a member variable. We need to create an object of the class first, using the syntax class name object name equals new class name. Firstly, we declare an object of the person class. Then, we use the object name, method name followed by parentheses. Because our method has parentheses, if the method has parameters, we need to provide the corresponding arguments. For instance, let's consider our person class. How do we call the method? We use the object name followed by a dot, and then the method name. After that, we pass an actual parameter argument. In the method definition, there is a formal parameter named food. So, when we say, I like eating food, what is the food exactly? It depends on the value we pass when we call this method. For example, if we pass watermelon, the system will output, I like eating watermelon. Next, let's see how we can call the eat method inside the person class in our code. First, we have already defined the person class. Now, if we want to call its method, we need to create an object. Remember, we must create an object of the person class to be able to call its methods. So, we define a person class object. Let's say P, using the statement person P equals new person. Now, the object is created successfully. How do we call the method inside it? We simply write P, eat watermelon. This call will execute the eat method inside the person class. As a result, we will see the output, I like eating watermelon displayed on the screen. This demonstrates how we can call a method from another class. That's what we have covered in this lesson, method definition and invocation. Thank you, everyone. Which of the following is the correct method definition in Java?